Hey everyone, this little video here is going to give you an intro to zero product property, which is what we are going to be learning about today. So here's the deal. We have been practicing a lot with factoring and changing the sum of a quadratic into the product. Up until this point, we haven't done anything with the product of the function, but now, moving forward, we are going to figure out why the heck we've been doing this and what we can do once our equation is written as a product in order to help us graph the quadratic, which would be a parabola on a graph, more efficiently. Okay? This right here, we're just looking at, you already know a lot about quadratic functions and you made several connections between them. Today, we're going to be looking at taking an equation and figuring out parts of that equation that will help us graph it. So there is something in math called the zero product property. What the zero product property is, basically, is when two things are multiplied together, all right, and they both equals zero, one of those two things has to be zero. So they go through and they give an example here. I'm not going to spend a whole lot of time on it because it gets a little bit kind of confusing. I think it's going to make more sense when we see an example. But pretty much if you are multiplying two things together like we are going to be when we have a quadratic written as a product, one of them is going to have to be equal to zero in order for the answer to be zero. Kind of like what we've known since we started multiplying way back when we were younger. All right. So here's what the zero product property means. And I'll make this slide available to you guys in your slides today so you can go back and look at that a little bit more. Okay. So basically, we are going to be finding the roots, also known as the zeros, and sometimes called the x-intercepts, by using the product. We know that when, all right, we have an equation and we factor it. So this was factored to x plus 10 times 2x minus 5. I didn't make us factor today. That's already factored for us. We know that if that were in the standard format, it would be equal to y. If we input 0 in for y, when y is equal to 0, that is when we will find the x-intercepts of a quadratic function. Remember, if you have parabolas on a graph, the spot where they cross the x-axis are our x-intercepts. Again, we're also going to call these our zeros, and we are also going to call those our roots. They're going to help us in graphing. Sometimes a parabola has two. All right, a lot of times a parabola has two roots or x-intercepts. Sometimes when the vertex is on the x-axis, there's only one. Sometimes our parabola has none, let's say when our parabola is floating up higher. So those are all things that we're going to talk about more in the future. But for right now, what we're going to do is we are going to take these two things and we're going to find the two roots. We had said before with the zero product property that if we set this equal to 0, like we did, so we took out y and we put in 0. Oops, sorry, paused it for a second. If we set these equal to 0, we have two different things that are equal. All right, so we have x plus 10 times 2x minus 5. One of those would have to be equal to 0 in order. So we are going to set that equal, each of those equal to 0. So if x plus 10 equals 0, that means we are left with 2x minus 5 is equal to 0, which we can go ahead and we can solve for x. This is just a basic two-step equation. 2x is equal to 5. Divide both sides by 2. One of my roots is going to be 5 over 2, or you can go ahead and put that as 2.5 if you'd rather have it as a decimal, okay? To find my second root, you assume that 2x minus 5 is equal to 0, and this is what you need to find the answer from. So you have x plus 10 is equal to 0. Subtract 10 from both sides. X is equal to negative 10. So my two roots of this equation are 2.5 and negative 10. This is helpful because if I were to graph it, I could go ahead and put a point way over on negative 10. I could put another on 2.5, and in a future lesson, we will figure out how to find the vertex in the middle, and then we can graph it. All right. So moving on from here, here's just another quick example, and we're trying to keep these videos short, so I'm going to be really, really quick. When we have x times x minus 5, again, we're going to separate this into two. One of them is just going to be x is equal to 0. The other is going to be x minus 5 is equal to 0. This one's already solved for us, so one of our roots is 0. The other one, x minus 5 is equal to 0. You add 5 to both sides, and you end up with x is equal to 5. Hey guys, I'm going to post a couple links that are going to explain this more in depth if you're still stuck. There is an IXL lesson today, and we're asking you for 20 minutes of practice. If you start working on those IXL lessons and you don't understand what you're doing, please, please, please reach out to myself or Miss Green, and we are happy to help you through this. We know that this is new, and like I said, we'll post that extra video in case you want more. All right, so that is zero product property, ZPP, in a nutshell. And again, please reach out if you need some help. Thanks so much, guys. Take care.